we are going to start the class soon, but I'd like to check you all have written. Ahmarul Islam Chaudhary, please write your ID number beside your name, because before the class starts, I would like to take a snapshot of the attendance. Those who are in before the classes start. Please, Ahmarul Islam, write your ID number. Good. Okay, just we are going to start the class soon. Before starting the class, I'd like to ask you whether you can hear the sound or not, and the thing you can see or not properly. Last class we discussed about the super mesh super mesh is already gone, and we have gone through the CT2 as well. And today we are going to talk about the new topic, which will be superposition theorem. So before starting the new topic, superposition theorem, I'd like to tell you one more thing, that I'm planning to go for assignment 2, assignment 3, actually I'm planning to go because of midterm exam is not going to be held, and as you know that marks distribution is done through the assignment and quiz, and also 5% to the final marks and 10% coming to the assignment. So as part of it, what I do, I will just add one more assignment, assignment 3. In assignment 3, what you have to do, I'm just going to give you a short description before sending you the assignment 3, what do you call that, question. The thing what you have to do here in assignment 3, it should be done group wise, actually, and in this group there will be 4 people in one group. Hey, all of you listen very carefully. 4 people will be in one group, and I will assign the group, and I'll send you the group name list, and you have to work together. Okay, that's the way actually the assignment 3 will be done. So what you have to do during the assignment 3, actually in assignment 3, I'm going to give you a particular very simple problem. For example, for node analysis, one simple circuit, or let's say KVL, one simple circuit will be given for the KVL under KVL law. Actually, you have to implement the circuit on the breadboard. On the project board, you have to implement the circuit with the resistors, and you have to apply the voltage source as supply voltage, and then you have to take the measurement using a multimeter. Like this very basic experiment you have to do, and you have to get the result of it, and you have to go for the theoretical analysis, theoretical calculation, then you do the practical measurement, and you do the simulation. These 3 things has to be done, and then you have to verify the 3 results, and these 3 results will be different from each other, and you have to write down in a single page report or 2-page report, in a simple report that I mean, one report you have to submit overall one. There you have to write that why the differences are. That's what for each of the topic there will be one circuit, very simple circuit will be given, so that all of you can understand it very well. Now, one circuit for each topic, one circuit for KVL, one circuit for KCL, one circuit for node analysis, one for mesh analysis, like this way, one circuit, very simple circuit, so that everybody can understand the differences between the theoretical values, simulation values, and the practical values. So this is the way actually you have to do group wise. So in a group, you have a very cost effective, very cheap, and I'll give you the details where you can get, how much is that, and this, that, and you have to do. Hey, somebody, Saad bin Haidar, what is your problem?
Sir, I'll have to do both hardware and software.
No, not
right?
not you have to. It is a group wise job actually.
Yes, yes.
4 person in a group. So
I mean hardware and software both.
hardware, software, and theoretical.
Oh, okay, sir.
theoretical calculation as well. So one circuit will be given to you, and you have okay, all of you are here present, right? Okay, I'm going to show you an example, then you can understand it. Okay, look at it. Can you see this thing? Hey, can you see the circuit?
No, sir.
No,
Oh,
sir.
none of you. Okay, okay. I'm sorry, I didn't share it. Okay. For example, if I go with this thing, can you see now? Hey,
Yes,
why you
sir.
say no, sir?
Yes,
Okay.
sir.
For
Yes,
example,
sir.
this is a circuit I'm giving you to prove a KVL. So what do you need? Well, two resistor only, 2K and 10K resistor, and 9-volt battery is required. So two resistors, 9-volt battery, and you don't need to go for 220 connections at all. So there is no chance if you want to die, you cannot die because 9-volt battery, it cannot kill you. You understand it? So
Yes,
it is
sir.
very
Yes, sir.
safe. It is very safe to do at home. Now you have to do it on the breadboard, on the project board. Project board is a very breadboard. Have you heard the name breadboard? Breadboard is what? In the morning you eat bread. That
No,
bread.
sir.
No,
Okay,
sir.
okay. You know that project board.
Yes,
I'll
sir.
give you the picture of this, all these things, and then you have to get one and you have to implement it on that one. As a simple example, I'm giving you and tell you how to do this experiment actually, and then you have to verify KVL from this circuit experimentally, and you do the theoretical calculation. Any children can do theoretical calculations, 9-volt V1 plus V2, and then what will be that way? You have to go and check it, and practically you have to measure the voltage, and these two voltages are the same, and current value you have to find through the ammeter. So one multimeter, simple 200 300 multimeter is enough, where you can measure the voltage and the current. All this information will be given in detail so that you will not having any trouble. But all think what I'm talking, this so simple thing will be given so that you can easily. All my target is so that you can understand it. This is the main target. Samit bin Hassan, go first.
Sir, can we use university lab
This is a blunder. What for?
like for this?
Because this is
So
very expensive, sir. I cannot buy it. Is it?
no.
Then?
Actually, some of us are outside of Dhaka, sir.
No. That's why let me finish. I haven't complete yet. I am going to tell you first and then finish. Then we can ask this sort of question. Okay, now let's come back to the point. What I'm going to tell you, 4% in one group. So among the four person, you have to divide the work in such a way. So one guy can implement in his house everything and share with everybody. Another guy will do the simulation. Another guy will do the theoretical calculation, and another guy will prepare the report. This way, actually, you have to divide your work, and you have to tell me how you divide your work among yourself. And everybody must have to have understanding about the practical, theoretical, and the simulation, all information, because I'm going to take a presentation on this, and you have to give a presentation group wise. And there, if somebody doing the hardware and you have no idea, you'll be caught. That's why I'm telling you, when you are going to do that, somebody is doing it, he can share in the online platform how he did it, explain to his partner so that everybody can understand very well. So in the presentation time, when I ask questions, so that everybody can answer the question. So Samit bin Hassan raised the question. One duck is living in Chittagong, one duck is Dhaka, and so how to do it all together at one person's home. No, I am not encouraging you to go in one home and everybody, all four guys are mixing together and transfer the corona to each other and then making trouble. I'm not asking you that. I'm asking you stay on your home and at your home, and one person has to do the whole, who is taking the responsibility, and it's not expensive, very cheap. But if 4% divide the money, it will be very much negligible. I can give you the estimation, because one experiment require 20K, 10K. Next experiment, this 20K, 10K will be used. So this is a common. So a couple of resistors you required, and that resistors can be used for different experiments. So it will be very simple in that case. It's very cheap as well. So you don't need to worry about it. Only the thing is you have to decide who is going to do what. That is the most important part, and I need to know that beforehand so that I also can ask question accordingly. So this is the way you have to do, Samit bin Hassan. So all four ducks are responsible for 4 tasks. One guy is practical, one guy is simulation, one guy is theory, another one is report writing and the presentation slide. So that at the end, I will give a date, and that date every group will come and give their presentation, and the Viva will be at the end of the presentation, question and answer session. And based on all these things, I'll give you the marks for this assignment 3. Yeah, now you can ask me question if anybody. Go ahead faster.
Sir, how many marks will be there?
Yeah, marks will be, I'll let you know the marks as well, because there are 3 assignments, 30 marks, right?
Yes, sir.
So 30, what common sense? Normally, I'm thinking that way. 30, yeah, equally 30, 10, 10, 10, like that way.
Yes, sir.
But we'll see after that if the load, I think that's the way. But let me finalize the assignment 3, and then I'll let you know about it. But I'll make it in such a way so that equally it will be distributed. Hey, who asked me this question? You are worried about it. Is it if more marks is better or less marks is better for you? What do you think? Ashikur, who asked me this question? Is it swap?
Sir, me. So more marks is better, I guess.
More marks is better. Now, less what? More marks, something like that you are thinking, right? So that one person is doing the hardware, you don't need to do anything. So you can escape.
No, sir.
Okay,
No,
now
sir.
I'll take
More
If it is a
learning.
group work,
Yeah.
sir, if 1 or 2 person do not work, sir, that will be very
Exactly,
trouble for the other 2. So,
exactly. That's why more marks is not suitable for this. But what happened? I'm telling you what. The four persons are distributing 4 tasks, as you understand, and you have to have a common meeting every time online so that everybody can share your knowledge to each other. Because at the end, when I ask you are going to go for presentation, everybody must have the knowledge about it. And if somebody says, sir, he did not share, then it is a big problem for him. So I think it's a very important thing you need to know before going for the final year project. Some sort of work flavor you can get from here as well. Okay, I think marks distribution, I'll let you know later at the end. Any other question?
Sir, do we have to record the when we are doing
Yeah,
the hardware?
yeah, you're very good question. At the time of presentation, you have to show the video demonstration in the presentation time. That
Okay, sir.
all the experiments are working and you got the result. That one you have to submit as well. Yeah, you have to record. You are living alone at home. I don't think so. You can ask someone to record it when you are doing the experiment. Should be fine. It's a good question. Excellent. That's the way you have to submit the assignment. One recording and another is a report. Report writing, I told you already. I'll let you know about it later. As you have to mainly the report writing should be focusing on why the 3 results are different from each other. They're very close, but different. Plus minus 5% deviation can be there. But why? That sort of investigation you have to do. Sort of things in the report writing, I think. It's okay. Hey, Sharup, what happened? You have any
Yes, sir.
question?
no, sir, no. Sir.
Okay, mute the microphone. And Ashikur Rahman, what is the question you are? Samit bin Hassan?
Sir,
Unmute, yeah.
sir, can we choose our own group member? Is there any option?
Absolutely, absolutely no. Because when you get a job after graduation in industry, you don't like your co-worker or colleagues. Will you tell the owner that I don't want to work in your company because I don't like the colleagues? Hey, are you going to tell?
No, sir, I got it, sir.
Okay, so
Actually,
you
it
need
was
to.
general question actually.
Yes, sir. So you need to be familiar with this sort of thing. Whatever dark head is there in your group, you have to adjust with that. This is the reality in your future life. Samit bin Hassan, you understand it?
Yes, sir.
So
I got it.
yeah, that's the way you have to. No, answer is no. Any other question? Okay, if no
Sir, the
question,
group list will be in bags.
I'm sorry.
The group list will be in bags.
Group list will
The
be.
group-
I'll make the group list and send it to you. I'm sorry, I could not understand your question. Is it what you are asking for?
Yes, sir.
Okay, or maybe you missed it. I told at the beginning. I will make the group list and arbitrarily, and you have to work. As Samit bin said that can we choose our group leader? No, that cannot be happened. Whoever will be your group member, you try to adjust with him. This is the reality in your future life. And I will make the group leader also. A group leader is not necessary. All the thing is required, the work distribution. That one you have to do by yourself. Once the group is made, then you have to decide who will go for the lab work and who is going to go for, I mean, the practical work, who is going to go for simulation, who is going to go for theoretical part, who is going to go for the report writing part. 4 tasks will be given among yourself. That one you have to decide by yourself. But report writing should be submitted all the experiment together. Remember, one report, group wise, one full report you have to, and slide presentation, slide you have to do, and the video. That one, actually, the guy who is going to implement the circuit at home, he will make the video. I think that's all about it. Hopefully, and I hope that you all understand. Is it okay? Any other question? If no,
Sir,
yeah,
sir, how many days will we get for completing the task?
how many experiment?
No, sir. How many days will we get to
Oh, days.
complete the assignment?
Okay, because you need to understand the all the theories. Otherwise, you cannot do it all the theories. So what happened? I will give you the question up to RC circuit. RC circuit, resistor, capacitor, RC circuit. So after RC circuit, you have to submit your assignment. So that will be before 2 weeks or 2 weeks before the final, the final exam. So I hope that you have enough time to do it. At least 2 weeks time you will get. I'm sorry, not 2 weeks time. At least 1 week time I'll give you to submit after the RC circuit. So you need to know all the what do you call that? All the theory, what the assignment related to. After that only you can submit it. So up to RC circuit you have to wait. Before RC circuit, no way you can submit it. So it may be before 1 or 2 weeks before the final exam. You have to submit it. I'll give you the deadline for the assignment 3 submission. So what you have to do, let's say the KCL, KVL is completed, node analysis, mesh analysis is completed. So the question with these 4 items, and today superposition theorem is going to be done. So 4 or 5 items, whatever the thing already completed, based on that, the question you can start answering, and you can make your circuit, you can go for video and sort of things. And at the end of RC circuit, your assignment 3 will be completed. After that, RL circuit, then the magnetic circuit, that one will be done. That one will not be included in assignment 3 because it's not possible to do it at home, because you have to use the 220 volt. I don't want to use 220 volt. Only the battery you have to use, and from the battery you get the result. So that's enough for you. You all understand it?
Yes, sir.
Good. I think if it's okay, if no question, we jump to the we can jump to the class. Okay, all of you can just look at it. If you can see the lecture, just a minute, where is that? Okay. Can you see the okay, sorry. Can you see the video? Can you see the lecture screen? Superposition theorem.
Yes, sir.
Okay, good. And now only the sound you have to think, check the sound is okay or not. Get the Viva. So Viva syllabus, and I can ask question like you are going to solve the ask me to solve. You are already semester and Tahmir. So I suggest you all to communicate him, upload it there, and you desired current signal or more than one. Okay, and from this communicate if you have any problem regarding this course. You'll be highly benefited. Let's come back to the superposition theorem. Can you hear the sound clearly? Hello? Oh, I'm talking to the live
Yes,
class.
sir.
Yes,
Okay,
sir.
Yes,
okay,
sir.
let's go. Let's see how it goes. The lecture I have already, I think, uploaded there, and you could see the lecture there. And if you see the lecture notes from the place, then you can see the first lecture slide given to the BUX is this one. Okay, and from this, actually, the superposition theorem definition, if you see that the response, that is what is response, the signal, a desired current signal or voltage signal or power signal, whatever, the current or a voltage in a linear circuit having more than one independent source can be obtained by adding the responses caused by the separate independent sources acting alone. This is what the superposition theorem. Now, if you take this example over here underneath a circuit, if I ask you that if you want to apply superposition theorem in it, the first thing you have to look at, this circuit must have more than what? More than one thing, must have more than one independent source. This is
More
first
than
thing.
one source.
Yeah, you have to look at it. Are there, how many independent sources are there? We can see how many sources there in this circuit.
Two, sir.
Two source, and these two sources are what
Two,
source?
sir.
Two
Voltage source, current source.
current source.
Two current sources.
Current source.
Yeah, two current sources are here. So this is a circuit where you have more than one source. So you can apply superposition theorem on it. This is the fundamental thing. And we can see how now superposition theorem can be applied to determine the responses. Now, what are the responses that what you are going to determine in this case are the voltage, because this V1 and V2, these two voltages actually are the responses we need to find from here. That means what is V1 equal to and what is V2 equal to, we are going to find from this circuit applying superposition theorem. So the voltages here are V1 and V2, that what we are going to find. These are the responses. Now we can apply superposition because it is having more than two, and it is a linear circuit because there's resistive circuit. So you all know that it's all a linear circuit here. Okay, how can you get the value of these two using superposition theorem? You can find it by adding the responses. Okay, by adding the responses. What responses? That is caused by separate independent sources acting alone. That means separate sources acting alone. That means one source should act once at a time. Other all will be deactivated. This is the thing. So one source means if you say that IA is active, but at that time the other will be inactive, and you have to find the value of at that time V1 and V2. That means V1 at V1, you can say V1 prime and you can say V2 prime when IA is active and IB is inactive or all others are inactive, one at a time active. Then you have to find that V1 and V2 prime. V1 and V2, you're finding those things we are naming here as V1 prime and V2 prime. When IA active, all others inactive, only IA is active, then you find the value of it. And another one is the IB is active and other all will be inactive. That's a blue one. In that case, you are going to find the value of V1 and V2, but at that time, the V1 and V2 will be assumed as the value of V1 prime, double prime, V2 double prime. That means these two value you are going to get from V1, V2 by considering IB active only. Okay, IB will be active only. Others are deactivated. That means IA is deactivated. This is how you are going to find these two sets of value for each source active alone. Then you have to add here. You have to add the V1 here as a V1. You write here as a V1 prime, V2 prime, and from the other one you are going to add them V1 double prime plus V2 double prime. That means what? That means the blue one and red one. That means active at a time, and then you are finding the response. Then you are going to add them. This is the thing. So we are adding. We are adding them like this: V1 prime plus V2, V1 double prime, V2 prime plus V2 double prime. This is the way we have to find the V1 and V2 at the end. Now let's go and see how it can do it. Then you can understand much more better. Now you look at the circuit. If we go to draw the circuit again, in order to make it much more clear how to do it, then it will be much more registered. This is 1 ohm resistor, and this is a current source. This is another current source, like that. Now these two current source, IA and IB, superposition theorem. And as superposition theorem, I said at a time one source will be active. So I said that first, if I say that IA is active, IA active, okay, that means the others will be deactivated. So what will be the circuit look like? Now if it is active, then very carefully you look at it, then it's very simple to understand. 5A is there. This is the resistance of 2 ohm, and this is the resistance of 5 ohm, and this is the resistance of 1 ohm. Okay, and what happened? A 10 ampere current source has to be deactivated because, okay, to the live class, I'm going to ask question. You have to tell me answers. You get 0.5. Mr. Ahmarul Islam Chaudhuri, can you answer how to deactivate the current source 10 ampere?
Sir,
How to make it 0 ampere?
sir, if you can short it.
You can short it. If you short it, then it will be deactivated. Right. Now I am asking to Mudassir Billah Nirjor. Do you agree with him? Hey, Mudassir, are you there? Mudassir? Mudassir, I'm writing here, you are absent. Okay. Now Borhan is not present, I think, and Ashrafur Rahman. Ashrafur Rahman. Yeah, are you present, Ashraf? No. Then I am asking to Aniruddha Sarkar. Trishit, are you present, Trishit? Trishit, Aniruddha Trishit, I'm writing absent here for you. You are not present. Okay, Sadman Ahmed, are you present? Sadman? Abdullah Al Numan, are you present? Abdullah Al Numan, are you present? No. Okay, I'm writing here absent for you also. Okay, no problem. Okay, you two guys all are absent. I don't know why it's like that. And now let's come back to the point. Next guy, Kaushik, are you there? Kaushik? Muhammad Kaushik, are you there? Hello? Oh, you are keeping me engaged and gone back home. Okay, Kaushik is not there. All right, no problem. Now next, so much wondered why you people are not coming. Okay, Tanvir Anjum, are you here? Tanvir Anjum. Okay, and then Khandaka Sajid Rahman.
Yes, sir.
What happened? All of you are absent today. I'm going to serious section. I'll take. Strange duck. Okay, now, yeah. Khandakar Sajid Rahman, can you answer to the question? Is he correct, or what will be the way to deactivate
Sir,
the current?
he is not correct, sir. We have to disconnect that part, sir.
So you have to open the current source
Yes, sir,
to
open
make
the
it
current.
0. That is
Yes, sir.
what you are saying, disconnect it. Okay, good. Only IA is active. Others all are deactivate. So the 10 ampere current source, I'm talking about IA means 5 ampere. I'm just writing here. This is not we should write here, it's a 5 ampere, it's better. So I'm writing here 5 ampere source is active. Okay. And what happened? 10 ampere should be deactivated. That means you have to take it off. So how to deactivate a current source? Can you tell me? Remember how to deactivate a current source?
Yes, sir. Open circuit, sir.
Absolutely.
Open
Because
circuit.
you started this thing in the
Sir.
super, in where? Last class we have seen in the super mesh that current source deactivate means you have to
Yes, sir. Mesh analysis.
mesh analysis. So you have to open it. Good. So you can just open now. How to open? You just cut it off. Cut it off. Take it off. So I'm just going to take it off. Then it is open. Now it is open circuited like that. So we are not going to draw anything after that because it is open here. So after that it is open. So no need to draw anything. Now we have to find the voltage at these 2 points. Now these 2 voltages will be now, one is a V1, another V1 prime we said, another one is a V2 prime we said. It's only one source, so it's a little bit different. Voltage will be coming. So one is V1 prime, one is V2 prime. Now, what will be this V1 prime and V2 prime? We have to find it and from this circuit. So if you want to find this value, how you can do it is very simple. Look at it. This is the current source. This is the current coming into this, and this is the voltage. The current division is going to be happened here. So V1 prime will be what? V1 prime will be equal to, I'm going to draw it. I'm going to write it here. V1 prime will be, V1 prime will be equal to 2 into the current, current flow through the thing, which is, I can say I2 ohm. So I2 ohm is Ohm's law, you know that. So 2 times, what is I2 ohm? Okay, real class, real life class, raise your hand, who can answer? What will be the value of I2 ohm, current division rule? You already know that. Okay, already raised your hand. Labib Rukoni, tell me the answer. Hello, Labib Rukoni, can you hear me?
Yes, sir.
Yeah, tell me what will be the I2 prime. Equation can be, you can tell me the equation also. 5.
Sir, it will be, sir, V1 minus V2 divided by 2.
Oh, no. V1 minus V2 divided by 5 is the current, this current,
Oh, sir.
right?
Sir, it will be 2 by V1, sir.
No, not 2 by V1. It is the current division law you have to. Total current is 5. It divide into through this 2 resistor. That is the current division law. Okay, Khandokar Sajid Rahman, can you? Current division law. I'm listen. Everybody can look back the class note. Current division rule equation. How we find the current division, and then you apply. That's okay. Yeah.
Sir, I2 equal 5 minus I3.
5 minus I3. Where you get I3?
Sir.
Okay, no problem. I think it's all right. Now you can see Swarup Kumar Sajid Khandokar Sajid Rahman told me this answer, right?
Yes, sir.
Okay, Swarup Kumar there. What is your answer?
Yes, sir.
Can you answer?
Yes, sir. I have to tell the current across 2 ohm, right?
I2 prime. I'm just another I2 ohm. Yeah, the current through the 2 ohm resistor.
By using current division law.
Exactly. What is that?
Yeah. 5 by 7 into 5.
Why do you get 5 by 7? 5 by 7
5 into 5
into 5. 5 by 7 into 5. Is it
Yes.
short circuited here?
Oh, no, sir. No, sir. Sorry, sir.
So you correct it and tell me. I'll give you opportunity. Go.
Sir, 6 by 8.
6 by no 6 by. Okay, 5 first. 5 is the current. Then
5 is the current, and then, sir, 5.
Okay, I you can go
Sorry,
ahead.
sir.
I'll come back to you. Mazed Hussain, can you answer?
Yes, sir. It will be, sir. 5 plus 1 divided by 5 plus 1 plus 2 into 5.
Okay, I think you are not correct. Okay, yeah. Why not you look at the last class note, the current division rule class note, and then you can find it from there. It's not the exam that you cannot look back. Imtiaz.
Yes, sir.
What is the answer? Yes, sir. That faster.
Sir, 3 by 2 means 1.5 ampere.
No, what is the equation?
Sir, equation will be 3 by 2 divided by 5 into 5.
3 by 2. Where you got 3 by 2? Equation, the total current is 5.
Yes,
And
sir.
it is dividing through the two resistance R1, R2. What are you talking?
Sir, I think I said.
Okay, now
right.
listen. Tanvir Al Islam. Okay, Tanvir Al Islam, why you raise your hand if you don't talk?
Sir,
Hmm.
the I2 equal to R2 divided by R1 plus R2 into I.
What are the R1, R2, and I?
So R1 equal to 5 ohm.
So
And
you
R2,
tell me the equation in value.
so R2,
I2 equal to what? Hey, what
so
is the
5, so 5 into 5 divided by 7, sir.
it is wrong. That is what Swarup Kumar
Sorry,
there told. R1, what is your R1? What is your R2? Tell me first.
Sir, R1 equal to 5 ohm and R2 equal to 2 ohm, sir.
That's it. You stop. You are wrong. Okay, now let's come here. Samit bin Hassan, go.
Sir, 5 divided by 8 into 2.
How you said?
Sir, 5 divided 5 plus 1 ohm.
Hmm.
That means 6. Then 2 divided by 2. Then equal to 8 and into 2.
Into 2. You are wrong. Okay, now let's come back to the next one. NBM Abdullah.
Sir, 6 divided by 8 into 5.
Where you get 6?
Sir, 6 means
This one.
I have,
Okay, okay.
Yes,
So, can you repeat?
sir, 6 divided by 8 into 5.
Good. Now tell me what is 5?
Sir, I didn't understand.
Okay, no, 5 is what? 5 is the current, right?
Oh, current, sir. Yes, sir.
And what is R1?
Sir, R1, sir. R1 is, I think, sir, 2, sir.
2. Okay, what is R2?
R2 is 6.
5 plus 1, right?
Yes, sir.
6. So your current division law said the current divided by summation of R1 plus R2 into what? Opposite resistor, which is 6.
Yes, sir.
And what's his name? Tanvir. Tanvir Al-Alam answered this thing is multiplied by 2. Not 2. It will be multiplied opposite resistor because you are going to find the current of through the 2 ohm resistor. If you find the current through 2 ohm resistor, you have to multiply with the opposite resistor. So opposite resistor is 5 plus 1, 6. And Saurabh, you understand your problem. Your R2 is not 5. R2 is 5 plus 1, right?
Yes, sir.
Yes, sir.
Most of you made a mistake here. These two are parallel. 2 and 5 and 1, 6. The 6 ohm and 2 ohm are parallel. That's why they. Okay. So now I think he is correct. Abdullah. Is Abdullah given me the answer, right?
Yes, sir. MBM Abdullah.
You are right. Absolutely. Look at it. Through the current division, this is the total current, and this is dividing into 2 branches. So current division rule, remember, total current 5 ampere divided by summation of the 2 resistance. What is the summation of the 2 resistance? 2 plus, what is the other one? Opposite resistance, 6. Good.
Sir.
5 and 1 is 6. And into opposite resistance, right? This 2 ampere current will opposite. What is that opposite resistance? If I want to find I2 ohm, opposite resistance will be multiply here. What is that value? R1, R2.
Yes, sir.
You cannot get me. 2 resistors. One is this, another
So
one is
shouldn't
this.
it be 6, sir?
Yes, it should be 6. It's very clear because this is R1, this is R2. So opposite resistance, if I want to find I2 ohm, opposite resistance is R2. R2 means 5 plus 1, 6. So why you're taking time? So it should be 6, right? So I'm going to take it off. I hope that you get it. It should be 6.
Sir,
So
question
I'm
from the
writing
live
it
class.
as a 6 ohm resistor. So 6, and then who wants to ask the question?
Mohammed Faikhader, sir.
Yeah, Fakhada, go ahead.
Sir, if these 5 and 1 ohm resistors were in parallel, then what will be the R2 then?
What will be the R2? Yeah, in that case, your 5 and good question, very good question. In that case, 5 and 1 at the moment, what you do? 5 and 1 you are is in series, right?
Yes, sir. That's why we're
Adding this, good. And if 5 and 1 in parallel, then you apply the parallel combination. What is parallel combination? 1 by R equivalent equal to 1 by 5 plus 1 by 1, right? And you can find it from there.
And about the V1 and V2 prime.
This is how you're going to find V1 prime, right? And you are now telling V2 prime, is it?
No, I was talking about the nodes there.
Node will be the same node because no, I'm sorry. Node cannot be, it will V1 and V2 prime will be the same node in that case, isn't it? If 5 and 1 is in parallel.
Yes, sir. So
only one node
we
is
just apply the parallel rule.
Yeah, you just apply the parallel rule. That's what I'm telling you. But in that case, V2 will be not there. V1 and V2 will be same in that case. If 5 is in parallel with 2 and 1, right?
Okay, sir.
Okay. Now what we are doing here, try to get it. Okay.
Sir?
Answer. Can you tell me?
Sir,
I'm sorry. Yeah. Who's that?
The Shaira.
Shaira. Yeah. Go ahead.
Sir, can't we solve it in by applying KCL, not applying the current division rule?
Good question. Node analysis. You can apply node analysis. That means KCL. You are applying 5 divided by V1 plus VR. You can do it as well. It's a good point. You also can do that. But current division is very straightforward. That's why we have done it. But if you apply the KCL over here, it's a node analysis. If you do, that means this is 5 and this is V1 prime divided by 2 and this one V1 prime minus V2 prime divided by 5. One equation you get. And again from here, another equation you get. V1 divided by 5, V1 prime minus V2 prime divided by 5 equal to V2 prime divided by 1. And then 2 equation you can solve and you get the value of V1 prime and V2 prime. You get the same answer.
Okay, sir.
A good question, very good question. But this is easiest way actually. That's why we follow this. But if you follow that, you get full marks. Now look at it. Good. Thank you very much. Anybody can do it and tell me what is the value. This is what your V1 prime. This is how you can calculate it. You know all this information. You know Ohm's law. You know current division rule.
3, sir.
3. All of you agree? 3 volt.
Yes.
Okay. Check. Everybody check it. Don't make a mistake there. Okay. Now V2 prime will be the next voltage. V2 prime we have to find. Now V2 prime, if you want to find, then what will be the V2 prime? The voltage across 1 ohm resistor. V2 prime is the voltage across 1 ohm resistor. What is that? 1 times the current flow. What will be the current? I2 ohm or I, this one will be what? What will be the I here going through? I what? 5 and 1, 6 ohm. Okay, so what will be this? I2 ohm or I6 ohm? Okay, I'm asking Atikur Rahman. Atikur Rahman, what do you think actually? It will be what? Should I write I2 or I6? In order to find V2 prime, which is the voltage across 1 ohm resistor. What is the current going through that? That current 1 ohm into the current is the Ohm's law, V2 prime. So what will be the current here? What will be the current going through 1 ohm resistor? Atik? Is it I2 ohm?
No, sir.
What?
So it's I6 ohm.
So why you are silent and thinking 1,000 years?
No,
okay,
sir.
now you wait and see the answer. Good. Hey, what is this?
Sir,
this 1 ohm resistor will be multiplied with the current. That will give you the V2 prime. Yeah, what is the question? Live class?
Sir, on the V1 prime equation, the answer should be 7.5.
Oh, it's not 3.5. It's not 3.
No, sir.
Hey, all of you agree? All of
Yes,
you
sir.
agree?
Yes, sir. 7.5.
Okay, good.
7.5, sir.
Okay, we'll check it. Just wait and see. What will be that current? It is I2 ohm or I6 ohm?
Sir, I6.
I6 ohm. It is very simple thing, you know. Okay, Ohm's law. Now, one is resistance I6. I6 through the current division rule, I6 will be what? Total current, exactly the same way I can do. Total current is 5 divided by summation of the two current, that is 2 plus 6 into opposite resistance. Opposite resistance is what? In this case, can you raise your hand? What will be the opposite resistance? Okay, Mazed Hussain, tell me what is that?
Sir, 2 ohm.
2 ohm, very good. It will be in this case because you are finding I6, so opposite resistance 2 ohm. Okay, good. Thank you.
2, sir.
So 2. 2, good. This is 2. This is the way, this is your I6 current. I mean, this is your I2
And
current.
1.25, sir.
Right. This is your I2 ohm. This is your I6 ohm. Now, this is current division rule. We have learned, we have studied. Yeah, what is that? 1 point? What's that?
1.25, sir. There is a
And the sir,
1.25, sir.
V1 is
Yes, sir. There is a
7.5.
correction in the V1, sir.
Oh, you don't know how to do the calculation.
Sir,
Your
there is a
case-
correction on V1.
I
Yes, sir.
understand it, but I'm talking about
2.5.
yes, sir. Whatever it is, I'm just asking you if you don't know how to do this calculation. Is the worse? Okay, what is the answer? 2 point?
2.5, sir.
Hey, correct or not? At least you should be ready with the calculator.
No, sir, it's 7.5.
It's
7.5, sir.
Oh my God. What is
Not 2.5, it's 7.5. Yes, sir, it's 7.5.
Okay, all of you having calculator with you?
Yes, sir.
7.5. I get
Okay,
7.5.
if you have calculator, then you tell me how many of you say 7.5? Raise your hand. You know how to 0.5. Rest of you, please. Fine. Can you see? Okay, now it is 7.5. All of you are saying we get these two voltages. What is that voltages? V1 prime and V2 prime. These two voltages we are getting here. V1 prime and V2 prime. Okay. So this thing we got from here. Now, next superposition theorems, next thing is other source active and this source will be deactivated. Now, let's go to the next page. The circuit you have to draw, the other source active and this source deactivated. So the other source deactivated means the 5 ampere you have to take it off and the other source should be kept. Okay, that means here we are going to say 10 ampere active. If the 10 ampere is active, then how the circuit looks like? Look at this thing. Let's go back to the 10 ampere here, 10 ampere here. Now, if 5
Sir,
ampere
I have a question here,
then
like
what
plus.
does it mean? It means this one. Yeah, what is the question?
Sir, when we were calculating V1 prime,
Hmm.
We multiplied the opposite to resistance
Hmm.
6, that is 5 plus 1.
Hmm.
In V2 case,
Mhm.
why is it only 2?
Because in this case, we are calculating this current, I6.
Yes, sir.
When you find the I6, then opposite resistance will be 2, isn't it?
So, sir, actually, we are only, when we started, we just multiplied it with 1 ohm.
Oh,
So
no, no,
shouldn't
no.
it be
No.
5 plus 2?
I don't think like that. Assume this is I1, this is I2.
Yes, sir.
When you are finding I2, you multiply by the opposite resistance. When you find I1, you multiply with the opposite resistance. That's it.
Okay, sir. And
So
one
this
last question.
this I6, which is I2 like something, is going through 5 and 1, same current, isn't it?
Yes, sir. One last question. Then why is it that we only took 1 ohm in the first part?
Because V2, we are going to find V2. V2 means the voltage with respect to ground to this point, which is nothing but the voltage across 1 ohm resistor, isn't it?
Yes, sir.
And if I ask you, you tell me the answer. What is the voltage across 5 ohm?
So it will be 5 minus V1 prime minus V2. Sorry, 5 by V1 prime minus V2.
5 is
Maybe.
the ohm.
Yes, sir. Sorry. V1 prime minus V2 prime by 5.
That is the current I6.
Yes, sir.
But I'm not asking you the current. I'm asking you what is the voltage across 5 ohm resistor. Because V1 prime is the
V1
voltage. Go.
Yes, sir. V1 prime minus V2 prime.
That's it. That's
Yes,
it.
sir.
V1 prime minus V2 prime. And the voltage across 1 ohm, it is only V2 prime, right?
Yes, sir.
And what is the voltage across 2 ohm? It is only the V1 prime, right?
Yes, sir.
So the voltage across each of the resistances are different. One is a V1 prime, one is a V2 prime, another one is V1 minus V2 prime, right?
Yes, sir.
Now you understand why V2 prime is across 1 ohm.
Yes, sir. I get it.
That's your question, right? Okay.
Yes, sir. Thank you.
Thank you. One you have to take it off. This one you keep it. This is called 10 ampere is active. So what to do? 5 ampere, how to deactivate? Again, it should be cut off. Take it off. Then only this 3 resistor and the 10 ampere is remaining. So we can say that this is the new circuit for 10 ampere active means this is what you can see over there as a 10 ampere active. So your 10 ampere here, this is 5 ohm, this is 2 ohm, this is 1 ohm. And this part you've gone because the source is taken off the deactivator. So up to this you can get. Now if I say that this is the blue circuit, then the value for that time, you have to find the V1 and V2. But this time it is V1 double prime, V2 double prime. Two separate value you are going to get. Now we have to find the value of V1 double prime, V2 double prime. How to find the value of V1 double prime, V2 double prime is our question now. Now, if you want to find V1 double prime or V2 double prime, we can find whatever, V1 double prime, then what will be the V1 double prime? You look at it very carefully. The current, total current 10 ampere is coming into the circuit and divide into 2. One is coming this way, another is going like this, and this. So same circuit. So the current 10 ampere is dividing into 2 parts. One is this, another one is this. One is your I1 ohm, and this one can be I. What is the total current resistance? I what? 5 and 2. 7. Good.
7 ohm.
I can write 5 7. So 10 ampere will be divided into 2 current. One is your I1 ohm current, another 7 amp. So a current division rule you have to apply. Now, if I say V1 double prime, that means it should be 2 ohms law. Say what? 2 into what is the current flow? I1 ohm or I7 ohm?
I7 ohm, sir.
Good. I7 ohm current is flowing through this. Now we have to find the value. 2 into I7 is what? To the live class, raise your hand. Who can answer I7 equal to what? Okay, I think Majid, you answered. Now Sharup Kumar there. If you can answer correctly, you get 0.1. Sharup, tell me the answer. I7, bit faster.
7 by 8 into 10.
I'm sorry, coming back. 7 by 8 into 10. Good.
Into 10.
Good. Current division rule said this time total current. Remember the current division rule I have shown you in the last page. Total current divided by summation of the two resistance R1 and R2. R1 is one resistor is 1 ohm, another resistance is what? Hey, one is this one, another one is what?
7.
R1,
7, sir.
R1
7 ohms.
plus R2. R2 is 7, like that, or whatever you say, R1, R2, other way around. Into opposite resistance. I7 is the current flow through the resistance, but you have to multiply it in the opposite resistance. What is the opposite resistance? Tell me.
One, sir.
1 ampere, 1 ohm resistor. Opposite resistance, as I7 is
ohm.
going through this. So opposite is 1 ohm. So it is 1. Swarup, tell me the answer. Otherwise, I cannot give you marks. Point 1. What is the answer?
Okay, sir.
First.
So 2.5. 2.5.
All of you agree with this?
Yes, sir.
Yes,
Good.
sir.
Now do the calculation. What I told you, I1 was I divided by, you don't study at home at all. Just class and then go. I1, I divided by R1 plus R2, opposite resistance is R2. And if I say I2 equal to what? Remember this thing, I divided by R1 plus R2, current division rule is this. Opposite resistance is R1. Can you remember this? Hey, is it okay?
Yes, sir. Yes, sir.
Yeah, this is, yeah, that's what I have done here. I7, I found I7 I found I7 equal to this in the same way I have found. Just try to utilize your brain. Okay, so
I1 ampere. I1
Good.
ohm, sir. Sorry.
Live class, all of you can understand. Now we are going to find V2 prime. V2 prime will be 1 ohm multiply I7 ohm or what? Is it correct? Raise your hand. Okay, Samit bin Hassan. Now you answer the question. What will be this? It's I7 ohm.
No, sir.
What is that?
I1 ohm.
Okay, if it is I1 ohm, then what will be I1 ohm equal to?
10 divided by 1 plus 7 into 7.
Good. And tell me the answer.
So
Right. Good. Opposite resistance in this case. Hey, what is the answer? Do your calculation. Tell me the answer. Others
Sir,
cannot give
answer
you.
is 8.75.
All of you agree? Hey, all of you agree with this answer?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, good. Let's go. 0.75. All of you check correct answer or not.
8.75. 7.5.
But you can do the calculation by the calculator because calculator is a very intelligent device. Your brain is not that intelligent because if you understand this V1 double prime and V2 double, how we did it, that is your intelligence, not the calculator, how fast you can.
Yes, sir.
Okay.
Yes, sir.
Okay, now look at it. We found V1 double prime, V1 prime, V2 prime, and over for I1 volt current source active. For the other current source active, 10 ampere current source active, we found the V1 double prime and V2 double prime. And superposition theorem said that if you want to find the V1 and V2,
Sir.
you have to add them. Yes, sir. What's wrong? Oh, it's not coming. Just a minute.
Okay.
In this
2.5.
yeah, 2.5. So 2.5 you write here and you get the answer here. And what is that? 7.5. What is VR active? How we did it, that is your intelligence, not the calculator. How 1 volt current source active. For the other current source active, 10 ampere current source active, we found the V1 double prime and V2 double prime. And superposition theorem said that if you want to find the V1 and V2,
Sir.
you have to add them. Yes, sir. What's wrong? Oh, it's not coming. Just a minute. Okay, so I think you can see that V1 and V2 should be added now and find it. Now let's go for finding this V1. So let's go here to write it down that V1 is what and V2 is what. Superposition theorem said that actually it's a cut down and back. I don't know, it's 40 minutes already over. Okay, whatever it is. Now look at it. What is VR 7.5 and V1 prime was what? V1 double prime? V1's double prime was 2.5.
1.25.
No, 2.5.
1.25.
V1 double prime is this one. 2.5, isn't it?
Okay.
In this
2.5.
Yeah, 2.5. So 2.5 you write here and you get the answer here. And What is that? 7.5 and 2.5 is what? 10. 10 volt, right?
10.
Okay. Now V2 prime, V1 dot prime, V2 prime, V2 prime is what? V2 prime is 1.25.
1.25.
Yeah, V2 prime is 1.25. So you put here 1.25 plus, and V2 double prime is what? V2 double prime is 8.75.
Sir, 8.75.
Yeah, what's wrong? 8.75. So you're going to put here, your screen is not coming there, right? It's a bit internet problem coming. 8.75. Okay, 8.75. I'm writing here. So you add now 1.25 plus 8.75. What is that? What is that?
10.
10 volt. Good.
10, sir.
So you are getting 10
10,
volt.
sir.
Yeah, 10 volt as well. So this is the answer to this problem. If this is the problem, what is the voltage here V1 and what is the voltage here V2, then answer is 10 volt, 10 volt. It means you got the point. 10 volt, 10 volt means if you combine the two source, 10 volt and 5 ampere and 10 ampere together, this is 5 ampere, this is 10 ampere. If this 5 ampere, 10 ampere you connect together, then it will be 10 volt, 10 volt. Now, if you try to get it in this way, that let's go to the circuit and then can understand it. Okay, now you see, I'm going to draw the circuit like this. Again, this one 5. If you implement this 10 volt, full stop. V1 is 10 volt, V2 is 10 volt, because this time 5 ampere and 10 ampere source both are connected together. You understand it? V1
Yes,
equal to this, V2 equal to this. The final value is this. This is the thing. Now, what does it mean? It means if you implement the circuit like this, look carefully. If you implement the circuit in the lab like this, that this source is not there. If the source is not there, will it be same result we'll get in the experiment? If you do the experiment like this, if you implement the circuit in the lab, will you get, or in the PSpice you simulate, whatever you do, will you get the result 10 volt, 10 volt in this condition? Yes or no?
No, sir.
Okay, a live class. Yeah, you raise your hand. Okay. I could ask you a question to Majid Hussain. I think you did not. Oh, Majid Hussain answer already. Sifat Jahan. Sifat, what is the answer you think? Is yes or no? 10 volt, 10 volt?
Sir, no.
Okay, what will be the answer?
So there will be voltage drop in V2.
Okay, what will be this voltage? If it is only 5 ampere, 10 ampere is taken off.
Sir, this would be, sir, I'm not sure actually.
You don't know. We have done already. Come on. We have already done the calculation, right? The 5
Yes,
total
sir.
current is divided into 2, and
Yes,
you
sir.
found what?
So it
And
would
then you
be,
found beyond
6 by 8 into 5.
what? 8 into 5.
6 by 8 into 5.
What is that?
Sir,
Okay, I think you cannot answer correctly. So let's go to Tanvir Islam. Tanvir Islam, you did not get the marks yet.
Say it will be 5 volts, sir. V1, sir.
It will be what? V1 equal to what?
5 volts, sir.
5 volt. Okay, no. Okay, then Fahim. Fahim
Yes, sir.
Fayaz. Fahim
Yes,
Fayaz,
sir.
tell me, what is the voltage will be? Not 10, then what?
So 7.5, sir.
What?
So 7.5, sir.
7.5, which is V1 prime, right?
Yes, sir.
When 5 ampere is active, that time it is V1 prime and it is V2 prime. So
Yes,
V1
sir.
prime is 7.5. What is V2 prime?
So 2.5, sir. 2 prime, sir, to 1.25, sir.
Right. So V1 prime is 7.5 and V2 prime is 1.25. So these two voltages will be 7.5 and 1.25. Good.
No.
No. Then what will be this? This will be what? 7.5 and this will be what? It will be 1.25. Good. 1.25. This is the thing happened actually. That means with one source, if you do this, you will get it. And with another source, if you go, like if you go back to the previous one, I'm going to redraw that. Okay, 10 volt here. Yes. Now, all of you look at it. Give me the answer. If this time, if 10 ampere is working, 5 ampere source is taken off, then will it be still 10 volt, 10 volt? Yeah, raise your hand. Okay, I'm going to ask the question first. Majid, Ashikur Rahman, Atikur Rahman. Atikur Rahman already got the marks. Khandakar, Majid Rahman.
Yes, sir.
Yeah, what is the answer?
Sir, V1 double prime will be 2.5 and V2 double prime will be 8.75.
Okay, you said V1, it will be V1 double prime and it will be V2 double prime. And it will
Yes,
be
sir.
what? What will be this value?
2.5, sir.
2.5. What will be this value?
8.75.
Okay, so V1 double prime, which is 2.5, V2 double prime, which is 8.75. Good. No.
No.
No. Yes, absolutely. It will not be this. No, what will be this value? V1 will be what at that time if you measure by the voltmeter? What will be this
2.5.
value? 2.5. Excellent. 2.5. This is this one. And what will be this value over here at that time?
8.75.
Beautiful. 8.75. So this is the understanding. So only 10 ampere source, it is the thing of the 5 ampere source, that is the thing. But in the lab, if you add both current source, 5 ampere as well as 10 ampere, if you connect both current source in the lab or in the PSpice simulation, then you will get what? Then, okay, 5 ampere is active. So if you see that both this one and this one, both are active now, then what voltage you get? You will get 10 volt and 10 volt here, right? Hey, all of you understand?
Yes, sir.
Okay.
Yes, sir.
Now, one guy, I'm asking randomly one question. Yasir Mahmood, are you ready to answer, Yasir Mahmood? Yasir, are you there? Yeah, you talk that yes, sir. Otherwise, how come I know your microphone is working or not? Unmute the microphone and talk. Yes, sir. Now, question. Yasir, can you unmute? Hey, Yasir, you understand what I'm talking? You tell me yes, sir, or no, sir. Raise your hand simply.
Sir, his microphone is hang. Sir.
Oh, that means no way to talk. This is a one. Yeah. Yes, sir. Then you are missing the point. I think you are not going to give the mark. Fix it first and come back. Okay, then I have nothing to do. You are going to be loser slowly. Jarif Jaman, are you ready to answer or your microphone also hang? Jarif Jaman?
No, sir.
Okay,
Yes, sir.
good. Answer it. I am asking you one question, simple question, 0.1 marks. What is the current flow through 5 ohm resistor?
Sir, for 10 ampere current, sir.
No, 5 ohm resistor. Can you see?
Yes,
I'm
sir. Yes,
asking
sir.
you, what is the current flow?
Oh, sir. Current flow. Sir, current flow will be, sir, V2 minus V1 divided by 5.
Excellent. What will be the value?
So value will be 1.25, sir.
Okay. Oh, you said V1 minus V2 divided by 5, right?
No, sir. V2 minus V1.
Okay, V2 minus V1 divided by 5, right?
Yes, sir. Yes, sir.
Now, what is V2? What is V1? And divided by 5. What is the answer? Put the value. What
Sir,
is V2?
1.25.
Hey, come on, man. What is
Sir.
V2?
Oh, sir, V2. V2 is 8.75, sir.
What is written here?
Sir, V2 is a double prime, right, sir, for 10 ampere.
I am
peak out.
asking you in this circuit. Why are you talking about double prime? I'm
Oh,
talking
so
about
for
this
this,
circuit.
so for
I'm
this
talking
circuit,
about- yeah, for this circuit. What is the current?
yeah, sir, for this circuit, the answer will be 0, sir.
Right. Why you go with double prime?
Sir,
Are you
sir,
okay?
first, no, sir, first I asked you that this is for 10 ampere circuit or for whole circuit. So you told me
No,
10
I'm
ampere.
sorry. I'm talking about the whole. Oh, okay, okay. Maybe it's my misunderstanding. I'm talking
Yes,
about the whole circuit.
Whole
Definitely
circuit.
whole
Oh,
circuit.
sir. Oh, sorry, sir. I thought for 10
Right.
amperes.
Okay, good. So it will be what?
Sir, 0, sir. Amperes.
Absolutely, because the voltage difference across 5 ohm resistor is same. This
Yes,
side
sir.
is 10, this side is 10. What is the drop? Voltage drop. Voltage drop is 10 minus 10, 0.
10.
So no drop, no current flow. So it is 0 current flow through these things. Absolutely good. Thank you very much. Right?
Okay, sir.
You get my point?
Yes, sir.
This is what the superposition theorem said. Now, if you do the node analysis of this circuit, or you do the mesh analysis and you find the V1 and V2, you know what is node analysis, you know what is mesh analysis, right? Hey, dumb, you know that?
Yes, sir.
Okay.
Yeah,
If
we
you
know
go
that.
for node analysis and mesh analysis, whatever, you find the V1 and V2. Node analysis can easily give you the value of V1 and V2. And you see the answer is 10 volt, 10 volt. You understand now? What is, I'm asking you,
Yes, sir.
understand? Yeah, you should get 10
Yes, sir.
volt, 10 volt. Yeah,
Yes, sir.
but that is a different method. This is different analysis, which is node analysis. But here we are applying what? Superposition theorem. As a superposition theorem also will give you the same answer. V1 is 10 volt, V2 is 10 volt. If you apply the node analysis, you also get the same answer. V1 is 10 volt, V2 is 10 volt. You understand my question?
Yes, sir.
Now, in the interview board, in the Viva time, if I have a position theorem, V1 prime, V1 double prime,
Sources, then what will happen?
can you tell me? Short circuited, maybe could not get it even. Impact current, and what means this is the voltage source with the make it 0 volt. If you 0 volt you want to make to deactivate, means it will be short circuited here, and deactivate the current source means to make 0 ampere current. And what to do? You have to open the source, and open the source means there will be no voltage and no current, I equal to 0 in that case. And short means this is short circuited, then voltage will be 0 in that case. So I'm talking to the live class. This one actually you all understand. I have already talked to you about it, and you already know that if there is a current source, how to deactivate the current source. Today also you saw, if you want to deactivate a current source, you have to open the current source. That is, this is the thing, current source is taken off. And how to deactivate a voltage source, you have to short it. This one in the last class we have seen. So it is nothing new to you, you know that. So this is already, you know how to deactivate a voltage source, it will be shorted. How to deactivate a current source, it will be open. Yes, you know that already, right? Hey.
Yes, sir.
Yes, sir.
Okay, that's okay. Now, one of your friend was asking me one question, independent source, if there is a dependent source. And this is the answer to that question, that one thing you go through this statement, then you can understand. Thus, if there are n independent sources, we must perform n experiment, each having only one of the independent source active at a time, and the all others are deactivated or zeros. But here is the answer to your question. But if there is a dependent source present, in general, it is active in every experiment. So this is the answer to your question. That means dependent source cannot be deactivated. It is active all the time. And I will show you one problem later on. Now let us answer I'm going to explain this statement. If there are n independent source, in the last example we have given, can you tell me how many, what is the value of n? Anybody? Open live class. You raise your hand if you can answer. In our last experiment, how many independent sources were there? N value is what? Yes, Sifat Jahan.
The 2.
Good, excellent.
2, sir.
2, good. One is a 5 ampere resistor current source, another one is 10 ampere resistor, which is IA, IB. Remember? So these are the two dependent or independent source. So there are n value is 2. There are 2 experiment we have done. N number of independent source means 2 n experiment. One experiment we have done here is this one, 5 ampere. This is experiment 1. Experiment 1 main. Third line is if there is an independent source as the dependent source, it will be active all the time. Okay, this thing we will see later, but I'm just showing you on this. I think you'll be confused. Rather, we'll see in the next, when the problem comes, that time we will see that. Okay, now can you see the problem? Example 1. All sleeping? Question. And this is the solution. This part is solution. So you see your solution 50% is done for you in this slide. Why? In the question, how many independent sources are there? Tell me. You have to apply superposition theorem. Use
2 independent sources, sir.
2 independent source. So how many experiment can be done?
2.
2. That means 2 circuit. So one source active at a time, all others deactivated. So 2 experiment, 1 experiment here, 2 experiment here. So experiment 1 and experiment 2 is done here. Now you tell me, in experiment 1, which source is active? This source. This how many? Is a 2 source. One is what? Current source. One is voltage source. One is the voltage source. One is current source. In experiment 1, which one is active? Current source or voltage source?
Voltage source.
Voltage source is active, right? That is 3 volt voltage source active. Current source is taken off because it is a current source. You want to deactivate, you have to open it, and it is open here, right? It is open. So you understand it? It's a very simple for the first experiment. And first experiment, the 3 volt battery connected in series with a 6 ohm resistor and a 9 ohm resistor. So Ix is actually coming through this, coming through this, coming through this, coming through this.
0.2.
Yeah, because no current is flowing. It's open circuit. This is open. So all the current Ix prime, look at it. This is important to understand. Ix prime is coming like that. This is also Ix prime. This is also Ix prime. Do you get it? This is first thing. So in this circle, all currents are Ix prime. Oh, in the 1 minute, it will be coming. So V by R. Good. So X prime equal to V by R is equal to 3 divided by 6 plus 9. And what is the answer? Here. What is that?
0.2 ampere.
6.9 equal to what? Or connection is unstable. Okay, just 1 minute. Okay, look at it, live class. I'm going to tell you this problem. Actually, you have seen that there are 2 experiments. One is this one, another one is this one. So in this experiment, the voltage source is active, and in this experiment, current source is active, voltage source deactivated. How the voltage source deactivated in the second experiment? By shorting the voltage source. So in this case, voltage source is shorted and it is deactivated in that way. So these 2 experiment you have to consider. And what are you going to find? You are asked to find the value of Ix. Okay, Ix you have to find. So first experiment Ix is Ix prime. Second experiment Ix is Ix double prime. So if you want to find Ix prime, what will be the Ix prime? If it is open, then the 3 volt connected directly in this is a circuit then. And what will be the current coming? The 3 divided by 6 plus 9, 15 is the current flow through that. And that is the current Ix prime, because no other current, because this side is open. So this part is not, no current is going through that part. So all the current is coming through this. This is the only circuit. So 3 divided by 6 plus 9 is the current flow through the circuit. And that is the 3 by 6 equal to 0.2. So the Ix prime current here coming here as 0.2 ampere. I think all of you understand it. This is very straightforward. And if the second experiment you go, that time the current source is considered voltage source deactivated. And voltage source, how the voltage source deactivated, I just now show you, it is shorted. So it is shorted here. And this is the voltage source deactivated. Now you have to find in this case the Ix, which is Ix double prime, because experiment 2. So this is the total current 2 ampere going, and a current division rule that a total current is going to divide into 2 parts. Now you have to find the current through this part. So what will be that current? That current Ix prime will be total current 2 divided by R1 plus R2. R1 is 9, R2 is 6. So R1 plus R2 into opposite resistance. What is the opposite resistance? 9 or 6 for Ix double prime?
6.
6
ohm.
You multiply 6, and that is the current. That is what happened. Ix double prime equal to 2, that is the total current, 2 ampere divided by 6 plus 9, that is R1 plus R2, 6 plus 9 into opposite resistance. Opposite resistance is 6, because you are finding this current means opposite resistance is 6. So it is 6. The total value calculation gives you 0.8. So Ix double prime is 0.8, and Ix prime is 0.2. So total Ix will be what? Ix is Ix double prime, Ix prime plus Ix double prime. Like last time you saw V1 is V1 double prime, V1 prime, V1 double prime. V2 is V2 prime, V2 double prime. Like that, in this case, Ix will be Ix prime, Ix double prime. So Ix prime you got from here, this experiment, which is 0.2. So you put 0.2. Ix double prime, you got 0.8, 0.8. So 0.2 and 0.8 is equal to 1 ampere. So the answer is 1 ampere. Using the superposition theorem, you got the answer is 1 ampere. Are all of you clear? Yeah, Samit bin Hassan, what is your question?
Sir, for solving this problem, can we, for example, 1, can we apply KVL? And for the second experiment, can we apply current division rule?
Yes, this is the thing happened actually. KVL is done here. In fact, straight away I have written, but if you KVL 3 minus 6 Ix prime minus 9 Ix prime, then from you are getting this.
Yes.
So that is KVL. Actually, you can think like that also. And this is current division rule here. You got the answer. Yeah.
So we can we can use different, like 2 different theorem for this
yeah, these are the basic law you can apply. KVL, current division rule, voltage division rule, everything you can apply here. But you cannot apply node analysis, mesh analysis.
Yes,
if I ask you, hey, listen, in the exam, if I ask you the question, hey, solve the problem using superposition theorem, and if you apply the node analysis or mesh analysis, then I think you cannot get marks, because that is another analysis. So you have to, just like you can get the answer, same answer you get, but you cannot apply those things here, because you are not asked to apply other analysis. But you should apply the basic law, and from the basic law you can get the answer. But superposition theorem, if you apply, there's a 2 experiment you are getting, and then you apply the basic law, mesh analysis and node analysis, then it is accepted. But if in this question means what? This is the diagram given and ask you Ix, find Ix, and you apply the mesh analysis here, you get 0, remember. And you apply node analysis here, you get 0. What you have to do, you have to divide into 2 circuit, because 2 experiment here, 2 independent source, 2 circuit you have to draw and do the analysis. When you're going to do this analysis, that time you apply the mesh analysis, node analysis, you can do it. But in the first question, the circuit given, here you cannot apply the mesh analysis. Here you have to apply superposition. Means this, from this circuit you have to draw these 2 experiment. After that you can apply whatever you like to apply. Node analysis, mesh analysis, current law, voltage law, KVL, KCL, but current division, voltage division. In this case, I'm sorry, in this case you can apply whatever you like. But in the question, it is asked that you know or not that from this circuit you have to do 2 experiment. After that you can solve the 2 circuit whatever way, doesn't matter. But first thing, this 2 circuit is 100% required, because this is the basis of superposition theorem, and you have to do it. Are you clear?
Yes, I got it, sir.
Thank you, sir. Thank you very much. We are doing the first experiment. So first experiment, if you go, this is the first experiment we are going to do. But in the first experiment, 2 ampere active. So if I write 2 ampere active, then I'm writing here 2 ampere. Okay, I'm just telling you, this is a very simple problem and very easy, straightforward, because you understand that 2 independent sources are here, one active, another deactivated, and another active. 2 experiments will be done. And in both cases, you have to find the ix. So ix prime and ix double prime, and then you have to add them, you get the answer, right? All of you understand it, that 2 experiment has to be, hey, real life class, do you understand?
Yes,
Yes,
sir.
sir.
Okay, now you look, I'm going to show step by step. You can easily do it. First experiment, I'm telling 2 ampere is active, but this 3 volt, 3.4 deactivated. How to deactivate it? Can anybody tell me how to deactivate? Short or open?
Short, sir.
Good, excellent. Because voltage source, it should be short. And then what will be the circuit look like? If you look, you can see the circuit should be look like this. Oh, it is to find what? The other experiment will be, this will be active, this will be active, the other one will be deactivated. That means plus minus 3.5 volt. And I don't know, hello, can you hear me? Okay, and now all of you see, this is actually deactivated because voltage source is shorted. So 2 ampere current source is active only. And this is the way, if you go, then the current division rule can tell you ix prime equal to what? The ix prime is going to be 2 divided by this R1 and this is R2. You can current division, you get 0.2. And the other part is 2 ampere is deactivated. If you go back to that circuit, if you go back to the, sorry, okay, now look at it. This is active and this is deactivated. If you want to deactivate it, you have to open it and 3.5 will be there. And 7 and 3 is 10 and this is 15. So 15 and 10 will be adding together, is going to be parallel. So you can find the current from there, but this part is taken off. What will be the circuit look like? You look at it. And double prime, remember. This is okay. The circuit is look like this. This is 3.5 volt and this is current sources. This one is open, current source gone. So this 7 and 3 is a 10 and this is 15 and this is 5. So this is the 3.5 voltage source. Now, what is the current flow through this? As ix double prime, if you consider, and then how to find the ix double prime? This is critical because ix double prime is going this way. So current is going this way, but this voltage plus is here, minus is here. The current should go that way. So whatever ix prime, double prime you're getting, that current will be negative. Look at it very carefully. Ix double prime. Again, Starnet is unstable. I don't know your health point from here. How to find the ix double prime in this case? This is a question now. Now, all of you try to get my point. Oh, you can see slowly. You can see, right? Okay. Now you can see. And from here to here, the voltage from here to here, the voltage is 3.5. Try to get my point. Voltage is 3.5. This is negative and this is positive. This is plus and this is minus. So what does it mean? It means ix, if you assume the current flow through this, current. Okay, can anybody tell me what is the answer of ix double prime here? The voltage across the 15, 7, 3, all the 3 resistance. What is that? 3.5 volt is up to this. Here to here is 3.5 volt. And this 15, 7, 3, altogether the resistance you know, voltage you know. So what will be the current flow through that? Ix double prime will be what? Anybody can tell me? Yeah, Sharp Kumar there. What is the answer? Bit fast.
0.19 ampere.
No, how you found it? You have to tell that.
I have first I have to find the voltage across the 15 ohms. Then
Why
I have
50?
to,
You got the voltage already from here to here. All the resistors.
yes, sir. I mean, all together, 7 ohm, 3 ohm, and 15 ohm.
What is that all together?
2.92.
No, the resistance is what?
Oh, resistance. Resistance 25.
25. And the voltage is?
And the voltage is 2.92.
Why do you look at it? What is the voltage from here to here across the whole resistance?
Across 25 ohms. 25 ohms.
And what is the voltage across 25 ohm?
25 by 30 into 3.5 equal to
No, it's all right. You are making it a mess. Okay, Samit bin Hassan, what is the answer?
Voltage will be 3.5.
Voltage will be 3.5 across the full resistance, which is the what is the resistance?
So 25.
25. Then what is the current?
Sir, current would be 3.5 divided by 25.
Excellent. Ohm's law. That will be the current and flowing through
0.14.
0.4. Ix double prime is 3.5 divided by 25, right?
Yes, sir.
Are there anyone here who can say the answer is wrong and why? Raise your hand. Samit bin Hassan.
Sir, I can say.
Oh, tell me what is that?
Sir, answer will be minus 0.14.
Right. Excellent. It will be negative because this is positive sign, this is negative. The voltage, this is plus and this is negative. So current supposed to flow in that direction, right? From positive
but
to
current
negative.
is flowing in the
opposite direction. That's why it is negative. Good. Current is what?
Yes.
If we call this current is 1035, I-25. This current is I-25. I-20 X double prime. Look, this I-25 ohm, the current flow through 25 ohm resistor I-25. Actually, IX and I-25 is in opposite direction. This is what I wanted to say. Now, all the answer together will be Ix will be now equal 0.66 ampere. All of you should get the same answer. You check. This is what the final answer you should get if you sum together 0.8 plus, minus 0.66 ampere. Should be fine. All of you agree?
Yes, sir.
Okay, good. Now
Yes,
let's
sir.
go. Yeah, good. Now let's go to the next example. We are going. Can you see a screen? Hello.
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Okay. Okay. Live class. This is a very important example, and that's the last example. So all of you try to understand. If it comes in the exam, this type of question will be coming in the exam.
Sir, how much time will it take? I have a class to join at 2.
At 2 o'clock. Okay. So who are you?
Saad bin Haider.
Okay, you just leave the class in time whenever and see the video record, and then you can understand it from there. The
Okay,
next
sir.
one.
Okay,
Okay,
sir.
let's
Thank
go.
you.
Okay, good. So this
So two experiment will be done here. Two experiment.
but how
will be
many
done.
sources? Okay, you all try to understand the question. Here also the question question is given here. This is the question and answer is there. That means the 2 experiment is done. But can you see there are 3 source but 2 experiment? Why? Because how many independent source are here? Can you tell me how many independent source?
2.
2.
Sir, 2.
Right, and that's why those who are having class at 2 o'clock, you can leave. Okay, that's why 2 independent sources are there. That's why actually 2 experiment is done, and you can see that 2 experiment, 2 circuits. Now we are going to see how it can be done. Look at it. You understand my question? How many
Three
sources?
sources.
3 sources. 3 sources,
Three
but you
source.
say, yeah, 3 sources, but you said 2 experiment. If 3 sources, there should be 3 experiment, right? What? Okay. Now, solution 50% is done for you. The 2 experiments. So what is the thing you have to find? The thing you have to determine is Ix equal to what? This is what our target. Now, if you go with this diagram, question, the solution B, the diagram B, where you can see what is active. 10 volt is active, right?
Yes, sir.
Okay.
Yes,
10
sir.
volt active. 10 volt is active. Forward. So KVL said what? 10 minus 2 Ix prime minus 1 Ix prime. And you got the answer In the second part, it will be very to the live class. You understand this point. Actually, for the first experiment, we can apply the KVL here because the 3 ampere current source is taken off because this is independent current source. In the middle there is no current source. So this is the first experiment, and we are going to find the current Ix through the 2 ohm resistor, which is Ix prime here. Second experiment, it is Ix double prime. But in this Ix prime here, what will be the current? If you want to find, you have to apply the KVL in this loop. If you want to apply the KVL in this loop, you can easily understand the equation coming 10 2 Ix prime minus 1 into Ix prime, and this is plus minus 2x prime is the voltage value, and this is 2Ix. When it is Ix prime, this will be 2Ix prime. You see, this is Ix double prime, that's why it is 2Ix double prime, remember. So dependent source variable will be changing according to that. So if it is 2Ix prime, then minus 2Ix prime, because it's a voltage drop, minus 2X equal to 0. So from this equation, straight away you can find the value of Ix prime. Can you tell me what is the answer? Any of you?
Sir, 2 ampere.
Okay, 2 ampere. How you found from this equation? You can straight away 5 Ix double prime, 10 equal to 5 Ix double prime. So Ix prime equal to 10 by 5, 2 ampere. Good. Now the second part, Ix double prime determination. So first part is very simple because you can apply the KVL directly. You can get the value of Ix prime. The second part is really tough. So how to find the value from the second part is our main target. That is the most critical thing. And if you can understand the second part, how to find Ix double prime, and then after that, what to do? Add this Ix prime and Ix double prime, you get the Ix. Your answer done. But Ix prime already you found here, as you said, 2 ampere. Now let's see how to find the Ix double prime. Very critical, because in the second part, when you go, then it is a question coming. How can you find it? Because this time Ix double prime you have to find. Look, to find Ix double prime, you can do one thing. What is the method you can apply here to solve it? You can apply the
we can apply nodal analysis.
Nodal analysis, that is the right I'm talking about. KCL, if you apply at the point, you can get the answer here. What is that? Nodal analysis have you done? Yep. Over here, if you apply the KCL, can you see these things? No, you cannot see. Okay, if you...
So we can hear you.
Yeah, I think you cannot see the thing. 3 plus 3, and then you are getting here 1 ampere, 1 ohm resistor. To the live class, just look at it first. I'm going to tell you up to this. This is the point where you apply the KCL. If you apply the KCL here, what is that? The 3 current, one current is coming in, one current is coming in, 2 current. This current coming in, which is Ix double prime, and this current is coming in at this point, which is 3 ampere current. Okay, another current is coming through this one. What is the current flow through 1 ohm resistor? So 3 current, on this current Ix double prime, another current 3 ampere. So this added another current, we assume this way, is also plus that current. What is that current? That is current through the 1 ohm resistor. What is that? That one will be this voltage minus this voltage divided by this resistance. What is this voltage? Hey, what is this voltage? This voltage is from ground to this. What is that? It is 2 Ix double prime, right? This is a voltage source. So from here to here, the voltage is 2 Ix prime. Do you all understand? Lab class
Yes,
people.
sir.
Yeah. So what will be the current flow? This voltage minus this voltage. Okay. At this point, what is the voltage? At this point, the voltage is V double prime. It is assumed V double prime. If you assume this is V double prime voltage, so what will be this then? 2 Ix double prime minus V double prime divided by 1. That is 2 Ix double prime minus V double prime divided by 1 equal to 0. So this is the total equation at this point. All of you clear? KCL.
Yes.
Live class, if you have a question, you can ask me. At this point, I applied the KCL. What is the, how many current? 3 current. One is Ix double prime, one is 3 ampere current, right? So Ix double prime 3 ampere current, plus this current. What is that current? That current going through the 1 ohm resistor. What is that? This one is this V1 minus V2 divided by 1. So what is V1? V1 is 2 Ix prime. V2 is V double prime. How? Because V1 is this voltage from ground to this. What is that? That is 2 Ix double prime. This is a voltage source. Do you know that this is voltage source? Hey, is it current source or voltage source? Dependent source.
Voltage.
Sir, voltage
Source plus minus voltage source. So what is the voltage? 2Ix double prime. That's why this is 2Ix double prime. What is this voltage? Or what is the voltage at this point? At this point, the voltage, consider the voltage across the current source. What is that? V double prime. So you assume V double prime. So 2Ix double prime minus V double prime divided by 1 is the current, equal to 0. Then it will be easy. Now you clear about the KCL over here. Do you get it? Are you clear or you have still question? Please tell me. Hello?
Yes, sir.
Do anyone have any question? Hello,
No.
do you have any question to understand? No, it's okay.
It's okay.
Okay, it's okay. Then next thing, our target is to find the Ix double prime. So in this equation, you got the Ix double prime here, you got the Ix double prime here. Only the problem is the V double prime. If you can substitute the V2 double prime into Ix double prime, then whole equation will be Ix double prime, and you can easily find the value of Ix double prime, right?
Yes, sir.
Okay, now let's go for V2 double prime. So V2 double prime is the voltage across these things, means this V2 double prime. If this point, you bring it here, short circuited up to this point, then we can say this V2 double prime is coming across 2 ohm resistor, right? What is the voltage across 2 ohm resistor? Across 2 ohm resistor, it is also V2 double prime. Do you understand it or not?
Yes, sir.
Yes, sir, because this is short circuited up to this point, right? If this is short
Yes, sir.
circuited, then from this point to this point, what is the voltage? Voltage is V2 double prime. So if this is V2 double prime and resistance is 2 ohm, current is Ix double prime, then Ohm's law, if you apply, then V2 double prime equal to 2 into Ix double prime, right?
Yes, sir.
Ohm's law, you can see here. Okay, now can you, V double prime is the voltage, V double prime is also V double prime across 2 ohm equal to 2 into Ix double prime. But do all of you agree, or there is some corrections? This is going through the, okay, this is my question to you all. As you said, this is plus positive terminal and this is negative terminal. Negative terminal is coming here and positive terminal coming here. And this is the voltage across 2 ohm resistor is V double prime. And 2 ohm is the resistor, voltage is, this is plus and minus V double prime, and current through this is Ix double prime. So Ohm's law, if you apply, you are getting V double prime equal to 2 Ix double prime. Is it correct or something wrong there? Yeah, tell me who. Okay, raise your hand, Laboni.
No, sir.
Labib Rukoni, what is the answer?
Sir, it will be, sir, minus Ix.
Absolutely good. Because this is positive, this is negative, but current going from the negative to the positive. That's why the relationship is negative. Excellent. So V double prime equal to minus 2 Ix double prime. Excellent. Good. And if you see, yes, it is the thing happened and it is written there. I'm sorry, it is written there minus. What actually? Okay. So you can see, apply, see, Vx double prime actually what? Okay, it is now you can, okay, it is Vx equal to V double prime equal to minus 2 Ix double prime. Now this V double prime, you have to substitute over here in this case. Then the whole equation will be in terms of Ix double prime. You can find the answer. Look at it. You now substitute this value into this equation.
So is it
0.6 ampere, then total value over here, Ix will, you are one step ahead. I think that should be great. Okay, let's see this point, this problem. So I think you all understand. This is, if you substitute this v double prime minus 2ix double prime, if you substitute here, then you solve the problem and you get the ix equation is coming here as ix double prime is coming here as minus 0.6, isn't it? Ix double prime plus 3 plus 2ix double prime minus, if this value is minus 2ix prime, and then you solve the equation and you will get the value of ix double prime is minus 0.6 ampere. Is it okay?
Yes, sir.
Good. If you get ix double prime is minus 0.6 and ix is what? Ix prime and ix double prime. According to superposition theorem, you have to add ix prime is 2 ampere and ix double prime is minus 0.6. And you substitute, you get the value, final value is 1.4 ampere. That's the answer to this question. This is the critical area. I think if you all understand it, you can easily answer in the quiz. When the question comes in the quiz or final exam, whatever, you can easily answer the question. If you understand this part, only this part is the critical part to understand the superposition for this problem. And you remember in this problem, there is a dependent source. So normally in the exam, dependent source will be present. So if the dependent source is present, you can see in each experiment, dependent source are present. You cannot deactivate dependent source anyway, never, ever in your solution, never deactivate dependent source. Dependent source should be present in every experiment. And here 2 experiment because 2 independent source, that's why 2 experiment. But dependent source is present in every experiment. And this is the way to solve the problem. I hope that all of you understand how to solve it. Similar type. Okay, time to come. So you can find the solution in this way. There are some other problems. You can solve it by yourself very easily. Now it is absolutely similar problem and I'm not going to show you. You can easily solve it. And I will upload this video as well, the previous video, so that the old video, you can have a look how it is solved. And it is very simple, very same. Yeah, absolutely similar way you can find the value of V2. And I hope that most of you can solve this problem by yourself. You cannot, just let me know. This is the way this problem you can find. And this is another very important problem as well. And these are the answer to all these 5 problems given here. You can check your answer as well. Okay, that's the number 5. That problem actually I'll send you by email and you have to try your best to solve that problem. That's all about your superposition theorem. I think you can easily understand. I'll give you this video and the previous video so that all of you can easily understand the superposition theorem well. I hope that's all for today. I hope that you all understand that superposition theorem you can apply in the practice problem, which is uploaded in the BUX.